Our next topic now is cluster and node availability. With this, it's important that you maintain business continuity by establishing a service level agreement or an SLA for your infrastructure and for your application. Now, for you to get there with AKS, there are a couple of things we want to take a look. The first one has to do with the cluster nodes. You want to make sure you have multiple nodes in a node pool. Now, for the reason for that is simple. If one of the nodes goes down for any reason, another node can pick up the workload. Up till now, I've been showing you this diagram where we have two nodes that are used for in the system node pool and primarily just used for the Kubernetes system resources. But what we do recommend really is for you to add a third one. So this picture here, if we were to just come in and fix that picture, what we're doing here is we are looking into having a third one there. So with that, what I have now is these three nodes. Again, our recommendation for this is to go with a DS2v2. And with this, you can really maintain high availability for the resources that are needed from the system. Now, as for the user node pool, the one below here in green, this will depend. At a minimum, you really want to have two VMs. So if you think about this, if one VM needs to be rebooted or if something happens, you really need the other VM to pick up the workload. In a better scenario, it would have to be more, but this will depend on the workload. The other thing you want to make sure here is that you don't really want pods to compete with each other. By that, I'm saying if you have system workloads and user workloads, and you will have some of that even in the user node pools, you want to make sure that they are not competing for resources. If you have more than one workload, let's say, for instance, if we go down into one of these user nodes in here, and let's suppose we have one application here, and I'm just gonna call this A1 here in orange, and then I have a few copies of A1 running, but now I have a second application, which could be anything such as like a monitoring application or just really like a third-party application that is running in the cluster. So let's suppose you also have that in here. And for this one, I'm just going to call this B1. That's a different application. Now, you want to make sure that when this happens, that you ensure that pods have the resources they need. So you can specify that on your YAML deployment file. With this, it's much easier for you as an architect or operator to predict how your workload will scale. You also want to make sure about the second thing here, which is setting up a pod disruption budget. And many times this is something that we don't look into in details, but you should definitely stop and think about this. The way this works is by you set how much replicas or how many replicas you are willing to lose in your deployment file during an upgrade or an update event. So think about that. If my application, I'm containerizing an application and it's running, and maybe it can survive with 2 replicas. Awesome. Put that in your disruption budget. Maybe it needs 5 replicas because maybe you're containerizing something that needs a quorum for it to work, right? There's an election. And maybe 5 is the number that you need. You can also put that, and you should put that in your pod disruption budget. Don't just leave that number with any number, or just don't, if you forget setting that, you might be actually harming your deployment and your application SLA. When you do configure that, just also make sure that when you're having multiple replicas, you do account for, there are events that, like hardware failures, this might happen, but there's also updates and upgrades where the disruption budget can help you out. Now, the other thing here, and then I'm just going to go into the second one here, and we're going to zoom in for a second. Let's suppose, again, we have these 2 applications here. And what I have here is namespace for the B application. So I'm just going to call this namespace B. And in that namespace, I then have little pods run for the B application. If we go and look at the other application here, so I have second namespace here. That's my second namespace for application A. And then I have little A pods running there. I can now ensure that my workload on that specific namespace have the resource quotas that it needs to run properly. You certainly want to do that, and you don't want to just apply something on a cluster-wide, because when you do apply these enforcements for quota just around the cluster, you might end up having a situation where third-party workloads that really don't have resources and requests and limits properly set up, they might not just work. So make sure that you really take a strategy of divide and conquer here. You have a per namespace, and then you go into those namespace and you set up the proper requests and limits in there for your pod. So whether that's CPU or memory or both, you certainly want to do that. That will increase your reliability. It will also reduce cost, because now we have a better way to predict how this will work, how my application will scale out. And one other thing to keep in mind with what we have in here is that you really, once you do that, and once you have an idea of how this works, you really want to ensure that every new workload that you're bringing into your AKS cluster follow these guidelines. One approach to estimate these limits is to have a baseline. So run an application, start with values for limits and requests, and then you gradually tune that up into a value that have a threshold established, and it's not causing instability to the cluster. By that I mean, if you run an application that is very hungry, let's say on memory, and you set up into a very low value, potentially what's going to happen is that the Linux kernel will just kill it with the out of memory killer. So increase that gradually and see if you can scale this out versus having a lot of things already pre-deployed with VMs and nodes that you're really not going to be using. So you end up having some cost savings by starting with a baseline, tweak it as you go. We'll leave some links in the description of this video about how to set up pod requests and limit, and how to enforce resource quotas.